next presentation, I would like to invite Mr. Wim Simons from TU Delft, and he will be given the lecture on the topics is global navigation satellite systems, GNSS observation to study vertical land motion in the Greater Bangkok. Please give your hands to Mr. Wim.
Sorry. So good morning, everybody in Europe. Good morning, everybody. Good afternoon, everybody in Thailand and other parts in the world. So unfortunately, although it was not easy, I've been able to come to Thailand because I also had some other work we had to do. So at least I could be present. And today I'm going to talk to you about the main thing I'm doing, my own expertise, well, the measurements I do myself related to the global navigation satellite system. My work itself is actually embedded in monitoring tectonic and man-induced land deformation in Thailand using geodetic space techniques. So that's what I'm going to talk about a little bit in general, and then I'm going to go on, as I was introduced to, with the topic on the vertical land motion of Thailand. Okay. So the contents of the talk today is, I'm going to watch to the right because otherwise my eyesight is not good enough to read on the other terminal. So some history on the GNSS research activities in Thailand by myself and by my university, TU Delft. A summary of the space geodetic techniques. I will talk there a little bit more in depth about my own technique, GNSS, and I will briefly introduce the other techniques, but then they are later on by my colleague, Mark Naye, and also my other colleague, Thai colleague, Dr. Anapo, is going to talk to you in more detail on. Then, of course, vertical motion in Thailand, that's important to get from the measurements that we are doing, especially if we talk about land subsidence. So the GPS can measure for us how much a point somewhere in Thailand is moving up. Well, that's not happening a lot lately, but mostly down. And we can get a very nice estimate about that over a long period, many years in time. I have to talk to you a little bit about tectonics, just to show you that also plays a role in there. Not that big for Bangkok, but still a little bit for the more southern, or more for the southern parts of Thailand. And then I'm going to show you some results we've done already for Phuket Island. Then I'm going to continue talk about GNSS stations in Bangkok. That's, of course, for this project what's going to be important. Some results we are doing, but of course, there are some results because we've been doing this for many, many years in other projects, and now we can use this data for this project, but we need to get some more data. I'll get to even try to come up with better results. So, I'll go on. The research activities, I don't want to go into detail, but what is important to know, the current ones, is that we ourselves, as TU Delft, are operating a number of those continuous GNSS stations. With the other satellite techniques, which my colleague will talk about later, the satellite measures to the Earth, and you get the data from the satellite as it is sent back. With the GPS or GNSS, which is the family name for all the systems, GPS has been most used because it has been around the longest. You have to collect the data yourself on the location where you want to know how much it is moving, in this case vertically, but also horizontally. So we have been having a couple of stations there. The oldest one is already since 2005 in cooperation with the Royal Thai Survey Department. Then we have installed another one near a tide gauge. I will explain to you, we're not aware what the tide gauge is, very briefly. Mark will do as well later on. And then we have another stations, actually 2 stations in southern Thailand in Phuket. These are the stations we have ourselves been operating, but there are many more stations in Thailand from other government agencies, and in this project, fortunately, we'll be able to use and look in their data They might not have as long time history as our own stations because we already started back long time to collect, but they will probably also be very useful. So we have cooperation for many years with universities like Chulalongkorn University, or Prince Songkla University, or the Royal Thai Naval Academy with Captain Samart. So the 2004 earthquake was for us, for scientists, a big scientific interest because it's changed a lot. Also in motions, vertical, horizontal, but also from the geophysical viewpoint. It was it was the first earthquake so big that was ever been recorded with GPS stations. Because the latest one before in Chile was in the 60s. There were no GPS satellites back then. So this was the first time. And that gives us a big opportunity to study, because these motions, they tell something about how the Earth responds. If you can fit, like Femke already explained, if you can fit the data with the model or improve the model because of the data, you can also use it to predict for the future how certain motions will evolve. So that's quite important. Okay, so the other things, we will provide the PDF also to you so you can read in detail. But of course, the focus now is on the vertical motions. And that's for Bangkok in this project and also still in the south of Thailand. And then we combine this with the other satellite techniques. So the techniques themselves, which are being used, there are 4 actually. 3 of them are coming from using satellites. The first one, the GNSS, as I mentioned to you about, the Global Navigation Satellite System, which you're all using also your phones, but we can get the accuracy at the millimeter level using specific scientific equipment. Then the other technique, the second one, is using a satellite. It's called the satellite altimetry. That's measuring the ocean height over a period of time. Then the next one is another satellite using radar, and we call it a SAR, synthetic aperture radar interferometry satellite it is. And that one is showing us deformation in a certain area. So it takes radar images like, let's say, 30 by 30 kilometers. And in that area, by taking the same image from the satellite, of which we have to know very precise its position, but that's also something which is done. We actually also work on that ourselves. Then you can see how the images change. So the radar images will be different, and then you can see in the same image how certain areas are going up or down. So that's also very useful. And then the latest one, that's a traditional technique, the tide gauges. They are basically located at the coast or river mouths, and they measure the change of the sea level over a period of very long time. They were already installed more than 100 years ago. So they just note, then you measure the sea change over a long period of time. So these are actually the main 4 measurements direct. But then, of course, the groundwater, which Femke mentioned, is also an addition to there, which I also put there, and rainfall, temperature, and river data. So mine, I just go on to the next slide where I zoom in into the GNSS. Yeah, so that's basically the technique. It works for the user quite easy because you just have to record the satellites signals coming to you from space on the ground, where you place your antenna. You see on the right, you see there's the antenna on the RTSD base station. There the antenna collects the radio signals, and it's doing that the whole day, day in, day out, year in, year out, and then per day from that, we can estimate the position of that antenna. Nowadays, we can do it horizontally, actually, at the millimeter or below the millimeter level, and in the vertical, that's a little bit less because there are no satellites below us. We only can see the satellites up, coming from right to left. We still get a couple millimeter accuracy. So if you can do that for 5 years, 10 years, and keep the same station, it will tell you how that station is moving. And then the vertical, which is you see on the right panel, the evolution there tell you something about how the station is subsiding, in this case, at the rate. It's not too high, but it's still significant if it goes on, because the rate is higher, I think, for this station than the sea level rise was in the past. So if the station is moving, downwards at a rate higher or equal or multiple times the sea level. Actually, then the land subsidence is the biggest threat in combination, of course, with the sea level rise. Because you have to both deal, you have to deal with your own city sinking at the same time the sea is rising. So the technique works just by a position in time. So you have the position 1 year here, the next year you have here, or the next day, but there are many days, and from that we can see how it evolves through time. Okay, so that was a bit too opportunistic. Go one back. Yeah. Okay, for that I don't want to go into detail, but we use a special scientific software. We have to do that. If not, we cannot get the millimeter precision we require for our scientific studies. And we have employed this already, this kind of work with many other universities and countries, but mostly Thailand, Indonesia, and Malaysia in a number of projects in the past, I think almost the past 2 decades. So, okay, so I move on to the next one. So what's important is if we use GNSS is to use the continuous observations. That means stations which are working day in, day out. You can also measure year by year. We call this campaign style, but that works as well. But you can imagine if you have data every day, you can even do a better job. And then what comes out of there, you can see on the right panel, that's we call a position time series. Now, the importance of GPS is, for our studies, is to collect or to have data over as much period as possible. Of course, GPS, the first GNSS system, only became fully operational by the mid-90s. So that's about the time where we can have the first data. Fortunately, we do for a number of stations. This station is another station I show you. What you see there is in the 3 directions. The horizontal direction, it's in the top panel. We call it, or the latitude, so the north in north-south motion. Then the second panel is east-west direction. And the bottom one, the important one for this project, is the vertical position change. And then if you have all those positions, which are all those black dots you can see there, you can estimate a trend line through that. So that means a trend. So same, the sea level rise gives you a trend, how many millimeter per year. We can do that also with the GPS. And then for the vertical, you can see actually that there also are seasonal variations, which are not a big issue, but you see the signal moving up and down through time. And that's something we're not too much interested in, because it's not really related to, well, it's a yearly similar cycle, but what's more important is the blue line going down, if you see from the west to the east. This is a station which is SPKN, which is near Bangkok at the Khao Phraya River mouth. We have installed back in the end of 2013, and so we have data for that for now already 7 years. One thing, if some of you might notice, that there is a jump there. That's actually a jump in the position. What happened, but not because of an earthquake, but that's something with the monument being hit by a car. We don't know. So, but that's no problem. We can estimate. But it's good to have your station not be interrupted by anything for all the years you measure, because sometimes they might build an office there and you have to move. So we try to keep the same position for a long time, the same stations as much as we can. Okay, this is the technique Mark will tell you about. I don't want to go into too much detail, but what you see here on the right bottom panel is the tide gauge data, and they see the clear increase in sea level rise in the last 100 years. And then, like in the last 20 years, we also have the satellites. We can measure this independently, so not using the tide gauge. Of course, if you still have the tide gauge data, you can combine. So you have an extra check to see. And then you can actually see, and that's on the upper panel, that's those last 20 years, which is the last part of the bottom graph. You can see that the satellites also give us the sea level rise. This is the global change. Now you have to know that, but Mark will tell that, he's the expert on that, that you have a global average, but still in different regions of the world, you can have a different number. It can be higher or lower. It has to do with the currents and how the sea works and temperature changes. So that's something you will hear from Mark later. Then we have the INSAR, which again, you get all the details from Dr. Anna Paul later on. But there you can see that we can measure changes in position in an image, either due to an earthquake, which you see on the left, or to the right, we call it human-induced, and that's because urbanization, a new area is being built, constructed, that mostly has to do also with groundwater has to change, or sometimes has to be pumped to lower it, to put foundations. Of course, you have the weight from the new buildings. They will also add, although that's not the biggest problem. And then when you see red in this one, in this figure, then red means that the sea level, that the land is going down, where the lighter yellow to green to blue colors show that that area is not deforming too much. So this is something we can get from the satellite, and verify. Now the tide gauge, as I mentioned, is less complicated, but still very valuable data. It is basically a paper roll in the old times, with a pen which is connected to the device measuring the sea level. And as the sea level goes up and down, as it does during the day with the tides, the pen follows and registers it on a piece of paper. That's how it was recorded for a long period of time. Of course, nowadays we can do it electronically, but it comes down to the same. And you just record the sea level for a long time. And we have all those stations around the world, but also Thailand has them. I think the Hydrographical Department operates some. I think Port Authority, there are more, DMR also, there are more agencies would do that for their own purposes. They have to know what's happening to the sea. So if you have this data for a long period of time, it can give you additional valuable data. So that's something else we're going to mix in in addition to our satellite data. So we go on to the next one. So that already was shown by Femke. So what I only want to show here is that where the red ellipse is, that's where I come in with the GNSS stations to contribute estimates on the vertical motion in this whole area, the Bangkok or whatever area I would like to study. But of course, in Thailand, we focused in the south of Thailand in the past, in Phuket. Still continue there, but now also we will do more work on Bangkok and see if we can improve on what we already have and expand it with new measurements. So I go on. So I have to talk to you very briefly about plate motion tectonics. So you have to know a bit about that because it also has something to do with vertical motions. As you know, the Earth crust is built up out of many plates. And those plates, they are floating on the, just to keep it not too complicated, they are floating on the hot fluid interior of the Earth. And they are moving in different directions. In some areas, they move towards each other. In some areas, they move away from each other. So that's where you get, for example, the big oceans when the two continents are being pulled apart. So America, for example, long time ago was connected to Europe and Africa, and then it drifted so because of the tectonic motion. So that those plates, they can cause many things. Fortunately for Thailand, you are quite far away, but you are also on a tectonic plate. We call it Sunda block or Sunda plate or Sunda land. It all refers to the same. And the plate itself can deform also even up to Bangkok. Although most of the actions, the earthquakes, volcanic eruptions, they happen near the edges where the plates converge. In this case, yeah, and that's, you all know, near Indonesia, Sumatra, you already know, Andaman, many earthquakes happened there in the past. So that's actually important to know. Now, those plates, as I told you, although most of the earthquakes happen on their edges, still they can deform up to many 100 kilometers inland. So it's like if you would push two things together or a piece of paper, you push it, it can move up, and when you then release the force, it will go back down. So that's actually also what happened to Phuket and to some extent to Bangkok during this, we call it a seismic cycle. That's the period in between very big earthquakes when the plate is doing something. And that also creates some vertical motions, which we also have looked into. To illustrate that, I'll see on the next slide. Yeah, so here that's illustrated. And there you can see that all those yellow arrows, they are the motion of those tectonic plates. And you see that they all move in different directions. You have the Australian, the Indian, the Pacific plate. You know all the Ring of Fire. Of course, the Ring of Fire is not coming inside Thailand, fortunately, but it's a well-known area where you have all those major earthquakes. And then you have this big seismic cycle, which if we go one time. Okay, so we have this seismic cycle, as I mentioned. You have before the earthquake, you have during the earthquake, you have after the earthquake. Okay, and those three phases are called interseismic, co-seismic, and post-seismic. Right now, we are, for this big earthquake of 2004, we are in the after earthquake phase. And that's also where we see some vertical motions associated with that. Okay, so that's, oh. So we have to go back. My pointer is getting trouble. Yeah, this one. So what we then see, when we come to the vertical deformation of Thailand over a period of time, we could see actually that before 2004, some areas in Thailand were slightly moving up. That's a good sign if you talk about subsidence. Unfortunately, this was mostly or more in the southern parts of Thailand, up to a few millimeters per year. So you see it's difficult to know, of course, millimeter per year if you're yourself standing there, but the science can measure it. But then we had this big earthquake at the end of 2004. And actually, after everything started to sink, not only Bangkok, but also Phuket. And we even had a rate at the beginning, I think, of like 1 centimeter in the first year, which is quite a lot. So this is just not to you confuse, we call it tectonic subsidence. And it has a cycle of going down, and then when the plates start to deform again, it's going to move up. So it's not a major or a huge problem, for example, for Bangkok, because it's only temporary and it's changing over a period of a couple hundred years. But right now we were in the down phase since 2004. In the island of Phuket, you can see that very clearly on the right bottom. You can see that before the earthquake, so that's about in the middle of the graph, you see that all the black points, although there is some noise and some seasonal variation, they were moving up. And then the earthquake happened, and then everything started to move downwards. But that downward motion now, at the end of 2018-19, was already slowing down. So it's not a big problem for Bangkok, but it is something we have to, just being the detailed scientist, we have to also take along. So now I just want to go to showcase what we have already did in Phuket, and where we have combined the GPS or GNSS data with satellite altimetry. We have not used the INSAR there because Phuket Island is a rock island, so we don't have a thick sedimentation layer as we do have in Bangkok. In Bangkok, the sedimentation layer is up to 2 kilometers thick. Phuket, of course, you see it's a lot of rock there. So it's not so sensitive to water extraction, groundwater extraction. It mostly is moving up or down as a result of these tectonics I show you about. We are using there in Phuket 3 stations for GPS and 1 tide gauge station. And we actually have put GPS on one of the tide gauge stations, which is measuring the sea. So we can also double check that the tide gauge station itself is not moving vertically up or down, in a way we would not know because it would give a false signal for the sea level rise. So the coast seismic, this is the horizontal area actually, has changed a lot for the whole Southeast Asia, and land moved a lot suddenly. Fortunately, well, the normal people would not, the public would not notice this, but it was up to meters near the earthquake in Indonesia and Thailand, even 25 centimeters. But this coast seismic phase was just during the earthquake. It already passed. So then if we looked to the motions, I don't want to go too much detail here, but a lot changed that before the earthquake, things were moving all the same in Thailand, or similar in the horizontal direction, but in the vertical, similar if it would not be affected by human-induced land subsidence due to, for example, groundwater extraction. But then after the earthquake, many things changed. There's two figures there. The one is the absolute, but the other one is the right one is with respect to the tectonic plate. So this shows how the plate itself is deforming and also affects Thailand with that. Fortunately, this is horizontal. This is millimeters. This is not a big issue at all for the general public. But we're monitoring as part of our research, which we also going to use for the vertical motion. So I'll move on. So right now, as I mentioned, we're still in this post-seismic, and then here you can see this very clear in Phuket. That's the reason also why we choose Phuket in the past. Phuket is located the closest for Thailand to the epicenter of the earthquake in 2004. So any signals we see due to the tectonic, we see the strongest in Phuket Island. At the same time, of course, we learn about the vertical motion, and we can apply this to our understanding, or in a new project, our research for Bangkok itself. So it's a long period of time that the motion goes back to its original motion before the earthquakes. In the horizontal especially, you see that it can last for decades, so 20, 30, 40, 50, 60 years. And also in the vertical, actually, we don't even know in detail. The scientists are still studying, and they need actually data as this over a long period of time to improve their models. And then they can tell us also a bit more mid detail, for example, for Bangkok, how much due to the tectonic Bangkok will still be sinking, although that's never going to be more than 10 centimeters in total. So that's not the big problem for Bangkok if you want to talk about sinking or prevent sinking of Bangkok. Okay. So in Phuket, we added the stations, and a lot of this we have done ourselves. I've done myself personally, because it's a balance trying to find the best station with the best visibility. So you don't want to put it next to an office which is blocking the signal from the satellites. You want to put it on an island, or not an island, on a foundation, something which is strong, which will not be destroyed by the sea or by construction nearby through time. So you set up this control point, and then you put an antenna on top of that, and then you program the receiver, the equipment. We use a solar panel so it can work independently. We use the data, mobile data connection, so it can send the data automatically. So if nothing goes wrong, it will work on for years. It has done so, actually. It has worked for this station for 4 years now. And we've been just to Phuket. We just came back from Phuket to service together with Captain Samart. And you can see the station still there. We actually had a very nice rainbow, so it's not the signals coming to the antenna, but it was a nice moment we could capture. We service, update firmware to ensure that the station can continue to gather data for a long period of time. Because I mentioned you need data over a long period of time. You cannot just do a project for 1-2 years and measure, and then after 2 years you know everything. That's not going to happen. So you need, in this case for vertical motion, in the case of Bangkok, we need data from stations which have 5, 10, 15, 20 years if possible. The new stations help, for sure, but to get the big overview, you need to have this for a long term. So it's a long time research you have to carry out. This is the other station we put. We actually put this on top of the tide gauge, as I told you. You can see on the roof there's an antenna there. And with that we can monitoring what the tide gauge is doing while itself it's measuring, the tide gauge is measuring the sea. But at the same time, we want to know what this whole structure, this building is doing through the years, because we need to know that, otherwise it will give a wrong measurement of the sea level rise. So for that we equip the station, and after we leave it alone and we only go visit it once a year, and fortunately this one is quite new. And we have 2 receivers just to make it redundant, so the one receiver break, we can still get the data from the other one. So that's the other data we have looked at. Yeah, apart from that, we also go to the field. We have the other points which we can still measure. This point there in Phuket, it's at the Promthep Cape. It's there already since 1994. So it's a control point, actually used by the Royal Thai Survey Department reference network for Thailand. So it's part of that, and it has been regularly measured for a couple of days each year. And this gives us valuable information. The same applies for points around Bangkok. So they're not measured every day, but they have been measured year by year for a long period of time. So they add, with that, they add to our science invaluable information. Of course, the station, you have to service there. You have to go there by boat. Due to COVID-19, I was not able to go there myself. That again, I don't have to go myself always, but sometimes because of technical things, it's good I'm there. But then I asked my Thai colleagues to go there, and they did a perfect job. I think this was in March of this year, to go there and retrieve the data and ensure everything was fine. And like this, yeah, we got more data from this station in Phuket. So I told you before that the accuracy or the position we can get with millimeter or sub-millimeter. Actually, what you see here, you don't have to know anything about math, but what you see here is the number of days. So each line represents 1 day of data, and then it shows you north, east, up, which is the 3 directions. You can have your horizontal position in 2 directions, like this. You want to know, and like this, and then in the height. So these are those 3 numbers you see. This is millimeters. Then in the bottom you see for the 2 stations, there's 2 stations there. The one station is PMBC, the other one is the station on the tide gauge. You see those numbers, it says 0. I have to do my best now to read my own, but it's sub-millimeter, 0 point something millimeter. So that means so accurate, a millimeter is very small, we can get, and the height you see is a couple millimeters. That's just for a week. But if we do that for a long period of time, we can really get very accurately, we can know how something is moving. And of course, other people can check the data. What we have done here is we have the 2 stations in Phuket. And now, just to be sure that the one station is not doing something which is the other is not doing, so it has, because for example, the whole structure of the tide gauge, due to a storm, or it's not well funded, not fixed to the bottom, it might slide, you know. We don't want to have that pollute our scientific data. So we use the one station on the coast, and then the other one on top of the tide gauge, and we just check the position every day in between them. And because they are close together, they should move the same, because Phuket is moving the same at that scale. If not, something is wrong. So by that we can ensure that the tide gauge platform, as you would also could do with the oil platform, for example, but then it's of course for a commercial reason. This is purely for the science. And then we can actually confirm that since 1 year, I think we have measured it. Before we measured it with just temporary, putting the GPS antenna, but it works better every day, that we confirm that the tide gauge station is stable, at least for the years, the period we have put the GPS on there. So that's something that gives us more grip on the data, and to be sure that we can say that this tide gauge data is validated also with its own vertical motion it has, you know, so we can add that. Because we talked about this before, relative sea level rise. Land going down and the sea going up, and the combination of that, of course, is a bigger effect. So land subsidence in Phuket is not due to human-induced, it's mostly due to tectonic, but smaller and not a big problem. This is actually the result for that study. We did that where we had data from Phuket Island for a total period of almost 25 years of data. So that's a long period, you know, and then you can really study any changes over that period. What we have seen there, of course, is that, as I mentioned to you before, that we don't know how long because we only have GPS data since the 1994, but we think for the last 100, maybe 200 years, Phuket was going up the island, well, not only the island, the area around it in the south of Thailand, around 3-4 millimeter per year. So for the people living on the island, that actually meant that they would see the sea going down. And nowadays in Bangkok, it's a bit different, but that's due to the tectonics. Then after the earthquake, the island started to sink. Fortunately, only for a short time. The total, I think, is there up to the end. I think it was around 12 centimeter. If difference with respect if no earthquake would have happened. At the same time, of course, the sea level rise has not stopped. So Phuket, after 2004, saw the sea level rise much quicker. Why? Because the island itself was sinking for a while, just a short while. So nobody in Phuket have to worry about that, because you can see it already started to become less. That's just part of this earthquake cycle. Now, Bangkok is a different story, because Bangkok was going, well, up or going nowhere vertically, but now we see strong subsidence, which will be shown later. The tectonic is just is a small thing in there. It's a detail, but not something I want to make anybody worry about. But the land subsidence is much bigger, you know. If the land subsidence, I think Dr. Anapa will show, is like 10 to 30 millimeter of 1 to 3 centimeter per year. And we all know that the sea level rise estimates are 3-4 millimeter per year. That's a factor 10. So if Bangkok would not move itself vertically, it would see the sea rise at a rate 3 millimeter per year. And it's per year, but at the same time now, if it's sinking itself by 30 millimeter per year, the effect is much bigger, you know. So anything happening due to sea level rise, climate change, is happening much quicker to a city which is itself suffering from land subsidence. I have good news for Phuket, actually. The coral reef, which we all know is endangered on many places in the world. In Phuket, actually, it benefited from this event because coral reef, especially the shallow water coral reef near the beach, if the island starts to sink, the coral gets more water on top of it and actually protects the coral a bit in these harsh times when there is coral bleaching due to warming of the ocean. So actually this was for the coral in Phuket. For some time it was actually nice that event happened. So it's not always all bad news because we are all suffering, well, the climate change has an impact on the sea, on the animal life, on people as well. Okay, so we're almost ending. Then what we also have looked at is actually my colleague Mark Naye is the expert on that. We looked at the tide gauge, which you see up there. So it's the measurement of the satellite looking at the sea. And there you see the sea was going up, sea level rise. And then in the bottom one, the one below, you actually see another graph, that's the tide gauge. In the tide gauge, you see something strange. It first looks like it's almost not going up anywhere. And why is that? Because before Phuket Island was moving up at a similar rate as the sea was going up. So for Phuket, it looked like the beach or the water didn't go up or down much. But then after the earthquake, Phuket Island sank a couple centimeters. And then suddenly, because we are sinking, the sea is still rising, the effect becomes bigger. What you see in the second part of the bottom graph, you see a strong signal. We call this the relative sea level rise is much bigger due to the fact that the island itself for a while was going down. Due to tectonics, but if it's man-induced like in Bangkok, you see that the effect becomes much bigger. So that's actually what I wanted to make you remember from this study in Phuket. Of course, in Bangkok, we're going to look at the total situation in Bangkok. Okay, so I move on. So this vertical effect, that's from the tectonic. It can have a couple centimeters also for the Bangkok area, but then again, that only could be once. I mean, it's going to stop. It's not going to continue. So the tectonic effect is also in Bangkok. We can still see it, but it's small. But if you would build a wall to protect, you could add 10 centimeters extra just to be sure, based on this estimate. Okay. Now it brings us back to, now we go to Bangkok. If at least the computer wants to take me there, yes. So we're going to look at the continuous GPS stations which are available. And then you can see that there's not so many there, but fortunately we have some, and some of them have been operational since more than 20 years. So for this study, we're going to look at those stations more in detail again, what their vertical motion is. Now we would like to have more stations, so I already contacted, and I've been cooperating for a long time with Thai colleagues, so I asked them also, although it's more recent data, there's more coarse or continuous stations now, but they've only been installed in the last 5, 10 years. But I asked them, please give me the overview of all the stations so we can check if we can include them. So if I go to the next slide. Oh, was one too much? Sorry, go one back. Okay, so those are the results for those stations we have ourselves in the Bangkok area. So you have to look to the right panel and to the left panel, the bottom one. The first two graphs on the other side is the horizontal. We don't have to discuss that. But you see that all stations in Bangkok show subsidence, absolute subsidence, up to 5 millimeter per year. This maybe looks less than what you expect of what you heard before, but we should not forget that all those stations, they are located on buildings, or they're located on pillars of a pier, which go 10, 20 meters down into the soil. So what the GPS is measuring is the subsidence below that, because the pillar is going down with the sand below it. However, we know that the top layer, from 0 to 10, 20 meters, the sand layer or the sediment layer can have much higher subsidence rate, because there the effect of water pumping and changing of moisture in the soil has a bigger effect. So you can have much higher rates. But that would be the minimum. If you would not have those upper layer, then you would still have 5 millimeter per year. So that's the same level of the sea level rise. But you'll see that we can even in certain areas of Bangkok have higher numbers. Okay, so I asked my Thai colleagues, please, do you have more stations in Thailand, GPS stations? And yes, they are. The Department of Land, Royal Thai Survey Department, there's many more there, and they all actually already are having contacts with each other. And of course, we are not interested in all of those stations. It's a lot of work, but if we then zoom into the Bangkok area, then it looks actually quite promising, because you see here again, those two red, the green one, and then the two yellow stations, that's the one we already were aware. But now it looks like there's still quite more than 10 stations additionally, and we talk about the greater Bangkok region, not just Bangkok city center. But that we expect, or we hope, we have to look at the data, we have to process the data, and see if also those locations are going to give us more information on the vertical motion. That brings me to my final, final slide, and then it's the conclusion and outlook. So the GPS vertical results, at least over the period of 25 years, they show, as a result of tectonic, that's smaller for the Bangkok area, but still a little bit present, or human-induced long-term land subsidence of 5 millimeter per year. But that is mostly for the soil below 20 meters. So in the upper level, you can still have much more sand compaction due to changing groundwater. So in this study, it's important for us to know, because I say 10, 20 meter pillar, but we don't know exactly. So we have to check for every of the GPS station how deep are, and we hope that the city town planning or other agencies, they can still know, find out how deep those pillars were, so we can know at what depth we are sampling the land subsidence. What is very important for us is that to have a long position time series over a long period of time for multiple locations in and around Bangkok. So that's what we hope. The stations are already there, so we're going to look at the data of the stations which are there now, and hopefully all the data, the data, how long they operate, we'll look at everything for each of those stations, and in the next couple of years, and then we hope to get a better picture using GPS data. And for that, of course, it's important for us to cooperate And we already, as you've seen, this is also the result on the previous graph. I already put some names from networks and other government agencies. We will have the data for other stations, and we will cooperate with them, and we hope we can share the data and analyze together. And actually, that concludes my talk on the GNSS part. So thank all of you, and my colleagues will give you more detail. So we have still some time for questions and answers. Okay, so there's more than the one system we use for the GPS, but we have one of them is installed, I think, near the city center. I think Sunam Luang, you have the old part. We have one of them which is close to the river mouth. It's Samut Prakan. We have one there. So and the other one is, I think, on the top of a building of Chulalongkorn University. So these are the three locations. So it's just a location. You could install it anywhere, but that's for the Bangkok area. And ourselves, many agencies have those stations, but the ones we control ourselves are mainly focused in Bangkok area and then Phuket. Yes. So I mean, the stations the question is, will the system be available for Thailand to use after the end of this project? So what we have done already, those stations we have set up for a long period of time. All the data is available, and what I have done, because normally if you have a project, you all know that you get funded or money for 5 years. The project ends, and then the equipment is abandoned or it's not serviced anymore, it might break down. We keep the equipment operating for sure. It has been until I retire, because it has become a personal hobby, and we get new funding. And the data also, of course, will be shared. So we hope that the stations will remain, at least the stations we operating ourselves, they will remain active. So thanks for the questions. Okay. Is there any difference of the sea level rise or land sinking between those presented in Bangkok and this year? I think the question refers to that there are many different results might have been presented, or how is this changing? First of all, I want to want to say something. Any study uses different data or different period of data. So based on that, you can have a different result. However, all the studies, I think, will have been presented. You have the World Bank or many other groups. Scientists have looked at us, not cooperating with us. They all come to a similar conclusion. So the sea level rise is really there from a global viewpoint. We can do nothing about that. It's due to the climate change. The land sinking has been seen in the past. It is changing sometimes when different areas of Bangkok are developed and there's a new area. But we have seen, for example, now that in the Samut Sakhon province, I think the Femke showed that already, there seems to be a lot of subsidence going on there. And we know that there's a lot of industry there. The Bangkok city center itself seems to be less severe cases of Bangkok subsidence, but you don't have to forget that the defense comes from the coast. So if the coastal areas are subsiding, the water will just be allowed easier to go. So the change from previous studies, I think we updated it, but they all come to the sound. There is a serious problem or threat from the sea level rise for Bangkok. Bangkok is only 1 to 2 meters above sea level. So you can do the math. If you have 5 millimeter sea level rise, you have 3 centimeter subsidence, that's 3.5. Now that's 10 years, that's already 35 centimeter. Below 30 years, that's 1 meter. So you can know that by 2050, if nothing would happen, and even the new report coming out from IPC today might even show a bigger sea level rise, yeah, then you know that Bangkok is going to be flooded, you know? It's not going to fall in the sea. So we update the results, we refine them, but I think all the researchers agree also for Bangkok that we have this sea level rise threat.